Hello, everyone. I am Ystallonne Alves. I'm part of Boxcat. We are a Toronto-based startup, and I'm pleased to introduce you our resolution enhancer, which takes advantage of Rigetti's platform. I'll be introducing a little bit of the concept of what it is super resolution. That can be simply defined as estimating a high resolution version of an image based on a low resolution input. That is a very complex task and actively researched topic on the computer vision community. And it has applications in many areas. It helps in face recognition, surveillance systems, medical imaging, and our focus at Boxcat is mainly on the multimedia industry. And here it's how we can connect computer vision and quantum computing. Our solution proposes an approach that combines the benefit of RASER, rapid and accurate image super resolution, and the variational quantum eigensolver. RASER, it's a method that was introduced by Google, and it was used on the image of the Google Plus social network, and it's also embedded on the Pixel phone, like the digital zoom feature. And essentially here, in the learning stage of the method, low resolution images are cheaply upscaled and then divided into patches. So it's smaller images that we can work with. And then using high resolution versions of those images, making a pair, the algorithm solves using the quantum computation a minimization problem. And all of that computation goes into a filter that consolidates the processing of hundreds, thousands of images. Here's a little bit of how this filter looks like. All of the values after being calculated with the quantum computer, basically we have statistics, local statistics of the patches. And then we can categorize them based on the angle of the gradient, of the strength, of the coherence of that gradient. And that can be easily accessed on the application side very fast. So here it's a little similar to the learning stage, but we have an image that we want to upscale, and then we cheaply up-res it with interpolation methods that are out there. And then we process, again, finding the key for that hash table that I just showed on the filter. So finding the proper statistics that we can apply for that patch. And then the output of it is a high resolution image at the end. And finding that statistics of the patch, we use the variational quantum eigensolver. Essentially, it leaves classical optimization and quantum processing, and we can go as small as processing a pixel at a time. So our Hamiltonian would be a single pixel in that loop. So in terms of like values, to preserve the integrity of the image and have the best output possible, we actually have more than enough values on the values that are output from the quantum computer. So even though on an exact calculation on a classical computer, we would have a value that is slightly different from the one that comes from the quantum solution, we have more than enough numbers to preserve the quality of the image. So here, in terms of quality assessment, we have classical and quantum classical results that are the same. So we are preserving the quality aspect of it. So we have an application that can go into any platform, and you can just run a batch of like images that you want to upscale. And we have worked with a major studio in Hollywood and small studios in Toronto on how we can integrate this in their media pipeline. So it's very smooth for them to use it. And we are about to release an extension for Adobe products. So this quantum power is touching designers and filmmakers. Right now, we are only giving 4 times more pixels, but we are working towards giving much, much more. And an important aspect here is that, oh, it stopped, sorry. An important aspect here is that this is a non-hallucinating method. So that means different from neural networks methods, we are not changing the image. So this has value for applications in medical imagery, for example, where the precision of where the features of like a cell needs to be precisely represented in the final output. And we are eliminating blurriness or loss of fidelity of the image as well. And an important application that is actually our goal here is to do rendering. So this could be incorporated into a hybrid approach for rendering, where rendering basically is converting a 3D model into a final image. That process can take something like 40 hours to render this 4K image. And in some very complex animations, that goes to 90 hours, 100 hours. It's actually 1/3 of the budget for any animation film out there. So we could actually render a smaller version of that image, let's say in HD, and then instead of using 40 hours to have the 4K output, we would incorporate our super resolution method and have the 4K image in less than 2 minutes with quantum computation. We are Boxcat, and if you would like to try any of the API or our extension, we would love to have contact with you. Send us your comments, your questions at hello@Boxcat. And we also have, you can Google a little bit about us and also have more like technical details if you want to go and understand a little bit more. Thank you.